You know, we all get budgets. We have them for our money, for our time, and we definitely all get deadlines. But what if the entire planet shared one single budget, and we were about to blow past the most important deadline in human history? That's what we're digging into today, Earth's carbon budget. All right, so let's get right into it. To really get a handle on where we're headed, we first need to understand what this budget even is. Now, I know it sounds like some super complex scientific term, but at its core, the idea is actually pretty simple. I want you to think about it like this. Picture a giant cookie jar for the whole world. For centuries, we've been taking out cookies, and those cookies are carbon emissions. The thing is, there's a limit to how many we can take before things get, well, really bad. And once those cookies are gone, they're gone. Okay, so to put it a bit more scientifically, the carbon budget is the total amount of CO2 we can still put into the atmosphere and have a decent shot at keeping global warming below that critical 1.5 degrees Celsius target. It's basically our planet's final spending limit. So this is where it gets real. Let's talk numbers, because this is where the urgency just smacks you in the face. How many cookies are actually left in that jar? Well, as of early 2026, we're looking at about 130 gigatons. Now, a gigaton is a billion tons, so that sounds massive, right? But here's the catch, and it's a big one. That number only gives us a 50% chance, literally a coin flip, of staying under that 1.5 degree line. And listen to this from Dr. Robin Lamble. Because our budget is so tiny now, even small tweaks in what we know about the climate can cause huge swings in that final number. We're not just walking a tightrope, we're trying to balance on a razor's edge. Which brings up a really important point about science, right? Scientists don't talk in certainties. They talk about probabilities. So what if a 50-50 shot just isn't good enough when you're talking about, the entire planet? And this is where you really see the trade-off. Look at this. If we want to be much safer, like an 83% chance of succeeding, our budget just shrinks down to only 30 gigatons. The more certainty we want, the less wiggle room we have. It's that simple. Okay, let's put this into perspective. Right now, the world is pumping out around 40 gigatons of CO2 every single year. The math here is brutal. That budget for the safer 83% chance, it's basically gone already. And the coin flip budget? At the rate we're going, we'll burn through that by 2029. So why this number? What's the big deal with 1.5 degrees? It's easy to hear that and think it doesn't sound like much, but we have to understand the stakes. What really happens if we blow past it? Going past 1.5 degrees isn't just turning the thermostat up a tiny notch. It's a whole different world. It's the difference between climate shifts that we might be able to handle and a future with way more extreme heat waves, way more destructive storms, and serious threats to our food and water. And then there's the really scary stuff, what scientists call tipping points. These are thresholds that once we cross them could set off changes that we can't reverse. We're talking about things like major ocean currents shutting down, massive releases of methane from the Arctic, or the permanent loss of the world's coral reefs. These are dominoes you really, really don't want to start toppling. And here's the kicker. This stuff doesn't just go away. CO2 builds up. The carbon from the very first factories is still up there doing its thing. Every single ton we add today is going to be messing with the climate for hundreds of years. That cookie jar doesn't magically refill itself. Okay, I know, this all sounds incredibly heavy, but the story absolutely does not end here. So let's talk about the path forward and how humanity is responding to this massive, massive challenge. So the roadblocks are real. You've got these huge political debates about fairness. Who should have to cut their emissions the most? It brings up tough questions about history, because the countries that industrialized first are responsible for a lot of the CO2 that's up there now. Meanwhile, other nations are trying to grow their economies. It's an incredibly delicate balancing act. But, and this is a big but, there is so much reason for hope. The technology is just exploding. I mean, the cost of solar and wind power has absolutely plummeted, making them cheaper than fossil fuels in a lot of places. EVs and battery tech are getting better and better. And just as important, you've got this incredible energy from people, from community projects all the way up to global youth movements, all pushing for change. Let's just quickly zoom in on one of those cool innovations, carbon capture. The whole idea is to grab CO2 right at the source, like a factory smokestack, before it even gets into the air. Then you transport that CO2 and lock it away for good, usually deep underground. Now, it's not a magic bullet that solves everything, but it's a great example of the kind of smart thinking that's happening. So what you should really take away from this is that there isn't one single answer. It's got to be a collective effort. It's going to take all of our amazing tech ingenuity, and it's going to take a massive dose of shared social responsibility, all working together. Which leaves us with the big question, doesn't it? The clock is absolutely ticking. The budget is almost gone. We have the facts, we have the tools, and we know exactly what's at stake. So the only real question left is, what are we going to do before time runs out?